like to invite you to consider the nature of what we see. We perceive things all the time. We're conscious of particular stimuli, colors, patterns, etc. But what is it actually that we are seeing? This is the question with which I was very excited to collaborate with Ivana on a project where what you see in flicker-induced hallucinations is not out there in the world, and you know it. The experience is you sit in front of a very intense flickering light between the frequencies of 5 to 30 hertz. You start to, with your eyes closed, you start to see patterns. You start to see moving dots and colors and patterns that merge into each other. And I will show you some samples of it that people have drawn or have mathematically simulated. When this experience happens, you're very well aware that these things do not exist outside of your perception. However, the experience is very real. There is what we were discussing with Ivana, there is a certainty that there is something that I'm seeing, and at the same time a certainty that this thing doesn't exist. There is this clarity of perception and ambiguity of the source of this perception, which occurs involuntarily, and you have no access to the source of this phenomenon. You don't know where it comes from. As a neuroscientist, if I sit in a laboratory in front of this an experiment which is set up like that, I would start thinking about the different brain regions, the connectivity between different brain regions that is enabling me to see this, the brain patterns that create these contents. However, in the collaboration with Ivana, I have had the opportunity to experience this this basically phenomenon outside of the context of a laboratory, which is cluttered, which is full of questions, which is full of competition and particular rules of science. I've been allowed, or I've been basically given the opportunity to look at it as a person, not as a subject of a scientific experiment. And well, the phenomenon is also used to diagnose epilepsy, and not as a patient. So only as a person who is faced with the phenomenon and is given enough time and space and a very white and minimal space of an art studio in order to reflect in silence on what this experience tells me about the nature of external reality and my perception. So I hope to share some of those thoughts with you today. What you see here is after reading a lot about the science of flicker-induced hallucinations, I thought the best way to be able to basically make a summary of how much within the past 200 years have been done scientifically on this phenomenon of flicker-induced hallucinations, I would make you a timeline. So if you can see from 1819, early 19th century, Purkinje was the first person who started with this phenomenon. And if I would like to go through every step separately, it would take quite some time. So what was interesting for me to look at this basically body of scientific knowledge was, what do we find? What are the similarities we find in all of these experiments? What is it? What is the common ground between them? And I found that one thing that occurred was that the method normally in science for capturing the subjective phenomena is either button presses or recording or making a verbal report or responding, solving a problem, providing a solution. There's always some way to measure behaviorally what is happening and, for instance, correlate that with what is happening in the brain. However, in this case, the experience is so ephemeral, it's so unmeasurable, which was another aspect that we discussed largely with Ivana. That one of the only available tools for the scientists has been to ask the people to draw their experience. So this is from 1819. This is from Purkinje's dissertation, one of the pioneers of neuroscience. And he used the method of just staring in the sun with eyes closed and spreading his fingers and moving them in order to induce something around 5 to 10 hertz frequency of flickering light, and draw very extremely interesting shapes that he actually even gave names like snail rectangle and 8-beam and honeycomb structures, which occur again and again within the past 200 years. These ones that you see are from 1979. These are not drawn by people, but these are mathematical simulations of what happens when you have particular dynamical systems that are comprised of perhaps interaction of very simple parts, which are detecting, for instance, orientation of particular stimuli, or are simply capable of detecting motion. And what happens when you have a dynamics between these very simple aspects of any given visual mechanism. And what they came up with were some patterns that were generated by their dynamical system formulas. Interestingly, you see very similar patterns in the drawings. These ones were from a paper in 2010. In the drawings of subjects in 2010, in 1934, etc., you see very similar patterns. So if you look at these patterns and those patterns and compare them to what the mathematical simulations on the basis of the exchange in dynamical properties of a particular visual system with particular properties look alike. This is one aspect of the similarity. There seems to be a very clear similarity among the patterns that are reported throughout these 2 centuries. But what does that tell us? You see your eyes closed. You don't know where these phenomena are coming from. You're basically hallucinating. And at the same time, the experiences that you have had and someone 200 years ago had at least have some similarity, some structural similarity. What does that tell us about the visual system? What does that tell us about the brains that all of us share many aspects of it with each other? What is similar in this experience that creates such patterns? Interestingly, these dynamical models, they found out that in hallucinations during epilepsy and also during mescaline-induced hallucinations or other kinds of drugs, and also in Charles-Bonnet syndrome, you get similar patterns. So it's not that it's absolutely the same. However, you do get structurally similar patterns. And so in order to find out the patterns that exist in what people saw, we started to do a number of simple statistical analysis on them that we are displaying here. Then we sat together and we took some time to look at what we are actually seeing. And so we were interested in questions like, what are the shapes that people are reporting? What are the shapes that are recurring? And as you can see, there were quite a few shapes that were recurring in everyone. For instance, almost everyone saw waves, circles, moving waves, different kinds of motion, different kinds of color was seen with everyone. Most people, different people reported different things, and basically the sort of quasi-experiment was performed also by artists. So we don't have all the data points. It was not meant to be a scientific experiment where everything is controlled. But with the few data points that we had, we could figure out what colors were occurring more and what less. And interestingly, a question was asked from the subjects that, as far as I know, none of the studies in the past 200 years have asked, which is, where did you see spatially, where was this experience located, this hallucination, where did it occur? And some people said that it was inside their eyes. Some people said that it was few millimeter away, or even 1 meter away, or it was as if their head was in a fishbowl and the experience was completely surround. And in fact, I was talking to Philipp Sterz, a vision scientist that works in Berlin, and we were thinking that this would be an interesting aspect to also think about scientifically, because there are different regions that are involved in the perception of space and the perception of visual percepts. And it is interesting to see what happens in the connectivity or the patterns in those regions when people experience a particular phenomenon completely in a different space than what another person has experienced that. Now, with this introduction, talking about the similarities, talking about the particular different recurring patterns and shapes, I would like to talk to you about something that is called the problem of perception. People like Tim Crane and other philosophers think that in case an illusory or hallucinatory percept can appear to me as real as something that is real, then our perception is not reliable. I call these, I would like to use a shorthand, I would call them the illusionists, or the illusionist arguments. This argument is basically saying, if my perception can be fallible, if you can trick it into me believing that something is real when it's not, then all perception is questionable. And we don't know whether the reality has a reliable structure either. Now, I find this a little bit too extreme. And I'd like you, like I said in the beginning, to consider what is it that we are aware of when we are experiencing something visually. What is it that we are aware of? One idea is, of course, one end is illusionism. We don't know, everything is not unclear, everything is uncertain, and our perceptual system can be tricked, so our perception is, according to Tim Crane, even impossible. And the other extreme is naive realism, which says everything that we see is exactly like that thing is in reality. Obviously, there is a problem. There is a very huge tension between the two, and I do not hold either of the views. That's why I'd like to invite you in the remainder of the talk to consider a particular solution or a particular position, which is a neuroepistemological position, which tries to figure out what the similarities that we saw can tell us about the nature or the let's say the about what it is that we are looking at when we are experiencing a visual percept. This is the major part of the argument that I'm going to make. First of all, if you see structural similarities in perception across many different types of hallucination, from flicker, from epilepsy, from drugs, from particular different kinds of illnesses, then it's very safe to assume that there are some structural similarities in the perceptual machinery that is creating these hallucinations. Now, what happens is that our perceptual machinery is tuned to the external environment, and it's attuned to particular percepts over millions of evolutionary years. And during these times, it has obviously, well, some parts of our visual system are much older, evolutionary speaking, than some other parts. Rods are much older than the cones in the visual system. But at the same time, it's been attuned to particular structural properties of the environment that all the us creatures, including humans, Homo sapiens, have been inhabiting. Now, these structural similarities, not only in the experience, but also when you open up the brains of different kinds of species, particularly mammals, you see very, very similar structures in the visual system across different species as well. These structural similarities, both in the experience and in the machinery of visual perception, can show us that there probably were structural similarities in the external environment to which they were attuned. Which is that, all right, our perception is fallible, but it doesn't end there in the head. It's not that, okay, because it's fallible, it's just me. No. The machinery, the perceptual machinery that when it's stimulated outside of its habitual zone, creates these kinds of hallucinations and illusions, is revealing some aspects of the visual machinery itself, which has been basically developing over millions of years, which is attuned to something that is outside of us, which is in our habitat. Now, I'm not going to make a very strong metaphysical argument. However, I'm going to make the argument that this shows that although our perception is fallible, but at the same time, we are at least like the last argument, their structural stability and similarity in our perceptual machinery reflects some structural stability in the habitat that we inhabit over millions of evolutionary years. And with that thought, I'd like to end with a quote by Wittgenstein, where he basically talks about how the world that we are talking about in the end is the world of sense data. I mean, the world that we experience is a world of sense data in the end. However, when we talk about things, we talk about objects. And this distinction between the experience and what we call objects, and how real is it, to what extent are there just structural similarities? Are these actual whole objects, like the naive realists say? This is basically the problem that Wittgenstein here and us during this project would like you to consider with the experience. Thank you.